On this next problem, we're going to look for a GCF first, and this problem does have a GCF. Notice that there's an x in all three terms, so we can factor in an x. Between 2, 1, and 15, there isn't any other GCF, numeric GCF, so we're just going to go ahead and factor the x out, which gets me 2x squared minus 1x minus 15. Okay, so after the GCF, now we're looking on the inside of the parentheses. Do I have 2, 3, or 4 terms? In this case, I have 3, so it's a trinomial, which is going to be a harder trinomial, and the reason it's a harder trinomial is because the leading coefficient is 2. Now there's two methods that we can use to find the hard trinomial. One is the guess and check, so 1x times 2x, and then the factors of c are 1 and 15 and 3 and 5. So I'm going to come off to the side of my paper and try those. I just picked 1 and 2 and put them vertically. I picked 3 and 5, put them vertically. I don't even know if this is going to be the right answer, but I'm going to go ahead and check it. So I'm going to try to multiply across and get 6x and 5x. Can I use 6x and 5x to get to negative 1? Well, yes, I can. That's with a negative on the 6 and a positive on the 5. So this factors into, don't forget the x, 1x minus 3 and 2x plus 5. Now the two parentheses can go in either order as long as you have them all. Now, if you didn't like that method, you could also use AC method, or we call it grouping. So we're going to take the 2 times the 15, that multiplies the AC to get negative 30, and I need to add to a negative 1. So then I go through the factors, and it turns out to be 5 and 6 with a negative on the 5 and a positive on the 6. So I'm going to break up the middle term to be plus 5x minus 6x minus 15. And then I'm going to factor out, let's see, an x out of the first group, which gets me 2x plus 5. In the second group, I can factor out a negative 3, which gives me a 2x plus 5, because a negative divided by negative is a positive. And then I can factor it into 2x plus 5 and x minus 3. Don't forget the x from the GCF comes down. I don't have enough space here, but it turns into the exact same answer. Number 16 does not have a GCF at all. It's a trinomial, 2, 3, or 4 terms. It's got 3, so it's a trinomial. And because the leading coefficient 8 is not 1, it's a harder trinomial. Again, you've got two methods. So one method is guess and check, where I can take 1x times 8x, or I could do 2x times 4. But the 5 only has one choice, so that's nice. So I'm going to try, let's say, 2x and 4x. And I'm going to try 1 and 5. And I don't know if this is the right combination, but I'm going to go ahead and try it. I get 4x and 10x with one of each sign. This says you have to have one of each sign. Can I use one of each sign to get to 6? Well, yes, I can. A negative on the 4 and a positive on the 10 gets you a positive 6. Those signs slip in, and my answer is 2x minus 1, 4x plus 5. That's guess and check. If you want to use the other method, which is AC, or I'm sorry, grouping is what we call it now. So I'm going to take 8 times 5, that's 40. I'm looking for multiples of 40. 1 times 40, 2 times 23 doesn't work. 4 times 10, that adds to 6. I could have done 5 times 8, but that's not going to add to 6, so 4 times 10 is it. So I'm going to split 4 and 10 up, a positive 10 and a negative 4. Once I have that, then I can do my two groups. I can factor out 2x, and that leaves me with 4x plus 5. In the second group, I can factor out a negative 1, which gets me a positive 4x, positive 5. When those are the same, you get 4x plus 5 and 2x minus 1. As a reminder, you do not have to do it both ways. Just one way to get the one correct answer. Also, the order of the parentheses doesn't matter. As long as the 4x is with the plus 5 and the 2x is with the minus 1, the order of the parentheses doesn't matter. For the next problem, no GCF again. 9, 12, and 4 don't have a GCF, and neither do the x's. The only difference here is that we have y's in there, okay? So again, this is a hard trinomial, which means I have to do it 2 different ways, and you just pick the one way you like. So for guess and check, I can use 1 and 9 or 3 and 3, and then 1 and 4 and 2 and 2. And now I told you to always try the 2 closest together, right? So this is technically 1x and 9x and 3x and 3x, and this is 1y and 4y, 2y and 2y. So I'm going to try the 2y and the 2y in the back. When I cross multiply, I get 6xy and 6xy. Can I use 6xy and 6xy to get to negative? Well, I can. This positive right here tells me the signs have to be the same. They both have to be whatever the second sign is, so that's both negative. So the answer is 3x minus 2y times 3x minus 2y. Now, another way you could write that is 3x minus 2y squared. Okay, if you chose to use the other method, which is grouping, you would take the 9 times the 4 and get 36, and we're looking for 2 numbers that multiply to 36, you add to 12. After you go through the list, it comes out to be 6 and 6. They both have to be negative because the positive on the 4 says the signs are the same. They both have to be whatever the sign of the 12 is. So I'm going to split this middle one. Now, please be careful when you're splitting this up. Because it has an x and a y, the 6xy, the xy goes on both terms. Some students want to put negative 6x on one and negative 6y on the other, and that's not true. They both have to be 6xy in order for them to combine like terms to make 12xy, if you were to go back in the opposite order. So I have 3x for the first group, GCF. Looks like I can take out a negative because the first term of the group, the second group, is negative, so I'm going to factor a negative 2y. So a negative 6xy divided by negative 2y is a positive 3x. A positive 4 divided by a negative 2, that's negative, and y squared divided by y is y. So my answer is 3x minus 2y, because they're the same, times the remaining 3x minus 2y. Again, you could also write it 3x minus 2y squared, because the two terms are exactly the same, the two factors. All right, our last one on this section is a no GCF. 2, 3, or 4 terms, it's 2 terms, and so you're having to try to figure out what binomial it is. Because of the minus, I know it's a difference. And because of the 3's, it's a difference of cubes. So I have, on the first one, p cubed. On the second one, it's 5q being cubed. If you remember, the difference of cubes has the 2 and the 3 factors. The first one, the 2 factor, the p and the 5q just slide right in. It's pretty simple. It's the second one, the trinomial, that gets a little tricky. So if you think of them as 3 products, the first one is p times itself. The last one is 5q times itself, 5q. Those are q's. And the one in the middle is a p times 5q. So p times p, that's p squared. 5q times p is 5pq, or qp, it doesn't really matter that much. And the last one's 25q squared. To finish this off, I'm going to use my SOAP. Same, so the original was minus, so this one's minus. O stands for opposite, so that's plus, and then AP stands for always positive. And that is my answer.